This lecture is on the structure of the semicircular canals. So the semicircular canals then are sensitive to head movement. That is to say, acceleration and deceleration, as are the utricle and saccule. Now, the important thing here is that the semicircular canals then are also sensitive to rotary movements. And in fact, these are major stimuli for these organs. And this is called dynamic equilibrium. And the receptors in the semicircular canals then for dynamic equilibrium. So by rotary motion, we mean spinning like this, and so on. So the receptors in the semicircular canals for this dynamic equilibrium then are called then cristae ampullaris. And more on them in a little while. Then, instead of having otoliths, to tell us where down is, as there are in the utricle and saccule, the semicircular canals are filled with fluid and they give us information about motion. And the motion detector is called the crista ampularis, and there is one in each semicircular canal. But before we get into the cristae ampularis, I need to tell you how these canals are arranged. So the arrangement then of the canals. So the semicircular canals are in the inner ear. You know that. They are connected to the utricle. And the semicircular canals are all set, that's an S, at right angles to one another, to each other. They are all at right angles to each other. Thereby describing three different planes of motion. Okay, so how do they manage to all be at right angles to each other? So, two of the canals are vertical and at right angles to each other. So you can imagine these then like an open book that you have standing up. So here we have our open book. Let's do it like this. Here's our book. And it is just standing on a table here. Like this. So here is our open book. And this then is a right angle here. So this book is just standing there on a table like then there's also the table that it's standing on. So we have two of the canals are vertical and at right angles to each other. And the third is horizontal. So it is like the table that these are standing on then, like so. And at right angles to the other two. So you have a right angle here, and then meanwhile, this is a right angle, that's a right angle. So all of these then are at right angles to each other. And if we were to then draw them as circular tubes instead, they'd be more like this, and this is where things get hard. So they're all, except that they all connect in the middle, which is hard for me to do, but just to give you an idea of how these things are oriented towards one another. So the easiest way to do this is actually just with my hands. So you have one vertical canal, you have another vertical canal, and then down here you have the horizontal canal. So all these things then are at right angles to one another and all connected together. So then getting back to the crista ampullaris then, so the crista ampullaris, and there is one crista ampullaris in each of these three tubes here. These all managed to meet in the middle, which I was unable to draw in successfully, but let's see if we can do this a little better. There we go. Anyway, so there's one crista ampullaris per semicircular canal, and the crista ampullaris then is a bump. That projects inward from the wall of each semicircular canal. So on the interior of each semicircular canal, you have one of these bumps. And remember, the semicircular canals are filled with fluid. And then within the bump, there are cells with hairs. You may be seeing a theme here. Everything, every nerve signal having to do with the ear has to do with bending hairs one way or another. So within the bump, there are cells with hairs projecting inward. I will draw this in a moment. And these hairs are all covered in one dome-shaped cap. Called the cupola. And the cupola itself is gel-like. So now I'm going to try and draw you a picture of this. So I'm going to start then with kind of the bottom of the bump. There we go. So these are support cells. Each cell has a nucleus, of course. So those then are supporting cells. And now I'm going to draw the hairs and the hair cells. Let's use purple for this. So we've got a bunch of hairs. Here we go. All right, so then these wind up connecting in with each other, like so. Like this. So here then we have hairs. And these now are your hair cells. And then on the side, we have some supporting cells. And these, I think I will label this in just so you can see what's going on then. So these, then, this, and this, then, these are fibers of the vestibular nerve. And then we have this gel-like substance on the outside. Maybe I will make that in green here. So we have this gel like so. So this now is the cupola. And then all of this together, this whole area here, that then is the crista ampullaris. So that's it for this. I'm just getting you started now on the structure. You now have the structure of the semicircular canals themselves. You have the structure of the crista ampullaris, and next time I will talk then about how it all works.